All right, now that we saw our log properties, let's go ahead and apply those. The pH of a solution is a measure of its concentration of hydrogen ions. This concentration measures in moles per liter, measured in moles per liter, is written H plus and is given by the formula pH equals log of 1 divided by H plus. So what is the concentration of hydrogen ions in the acid rainfall? So we have a chart over here given the different pH levels of orange juice, acid rain, clear rain, healthy lake. Acid rain is the one they want. They're telling us the pH level in acid rain is 4.5. So we're going to use that 4.5 in our formula. We're going to substitute it in for pH right there. So we're going to write 4.5 is equal to the log of 1 divided by H plus. So we can see that we're taking the logarithm of a fraction. We will use the quotient property to expand this logarithm. So 4.5 is equal to, when you're taking the log of a fraction, we separate out that numerator and denominator, and we expand it with subtraction, log of 1 minus log of H plus. So we're getting closer to getting that H plus alone. All right, so do you notice how we have log of 1? We have a log property that defines log of 1. I'm going to write it above our little pH chart. So off here to the right, we know that log base b of 1 is equal to 0. Now, it does not matter what the base is. Log of any base, with any base of 1, will equal 0. So we can come back to our equation and we can replace log of 1 with a 0. So we have 4.5 equals, instead of log 1, we replace that with a 0, minus log of H plus. Now 0 minus log of H plus is just a negative log of H plus. So 4.5 equals a negative log of H plus. We don't want that negative log. That's like a negative 1 times your log. So let's divide both sides by negative 1. 4.5 divided by negative 1 is negative 4.5 equals positive log of H plus.
So from here, let's just go ahead and take this out of log form and put it in exponent form. Because, where do we go from here? I don't know what log of H plus is. I know it's equal to negative 4.5, but we can actually isolate or get that H plus alone if we go from log form to exponent form. So to get it into exponent form, we want to identify the base of our log. At the beginning, we said that's a base 10 because it's a common logarithm. So 10 raised 2, remember our logs are equal to the exponent, so raised to the negative 4.5 power is equal to whatever we were taking the log of, which is H plus. So look at that. We have gotten our, well, do we keep the brackets around? I don't know what those brackets mean. We'll assume they're important. So we have solved for H plus. So then we grab our calculator. H plus with brackets is equal to 10 to the negative 4.5 power. So you type that in and you're going to get something that looks like this on your calculator. If you're using a graphing calculator, here's what it looks like. 3.16227766, and then you have an E and a negative 5. If you're not using a graphing calculator, this is going to look a little bit different. I don't know if it'll have the E, but this is how your graphing calculator shows scientific notation. They're saying it's 3 point whatever times 10 to the negative 5th power. We don't want to leave an answer that looks like this. We want to take it out of scientific notation. So we're going to take our decimal, because it's e to the negative, or e negative 5, that's times 10 to the negative 5 power. We're going to move our exponent 5 spots to the left. So you're going to move it 1, 2, 3, 4, 5. So h plus in the end is equal to 0 point, and then we moved it 5 spots. I'm going to have 1, 2, 3, 4 zeros, and then the 3. So here's where the decimal was, and we moved it 1, 2, 3, 4, 5. So this is a really small number. And then I'll just say 3, 1, 6 and call it good. And our, what are these? The concentration of hydrogen ions is measured in moles per liter. So we'll just put a label of moles per liter. And this is the answer we were looking for. So we applied our properties of logarithms to isolate the H plus and get that alone. Nice little scientific problem for you. And now we have the skills to do this.